the speaker. And it's my pleasure to introduce Laurent Raufaste from Percolate. Laurent has helped to build web startups for the past 15 years and worked on both the software and the operations side, so he's a true DevOps guy. And Laurent's professional career includes stints at the search engine in France, Voila, and the blogging platform Overblog, and amongst other things. And he's now the lead engineer at Percolate, focused on infrastructure and data. And Percolate, I'm sure Laurent will tell us more about this, but it's a software as a service, if you can say that. And it's my pleasure to welcome you to the CFEngine meetup, and thank you for coming and telling us about
a couple of pictures.
Thanks, Mark. Thanks. So, CFEngine on Amazon Web Services, a stateless infrastructure. I hope you will understand what this means at the end. So, hello ops. I guess a lot here are ops people. So, hello everyone. I work at Percolate. So, what Percolate does is, just to give you a brief version of what we do, we help big brands from Fortune 500 companies to figure out what to say on the internet, on Twitter, on Facebook, on LinkedIn. Those companies are used to produce like multi-millions dollars campaigns, but they don't really know what to say on those social networks. So Percolate is just crunching the web to know what to tell those brands what they should talk about. We are a technology company. We are not a marketing company, we are a technology company. We are focused on technology. And we are a SaaS, software as a service. We live in the cloud, we love it. So what our infrastructure is doing, we use a bunch of servers. 5% of them are serving data to our customers. 10% are doing chores. What I call chores is really like auxiliary tooling, like Jenkins, sending emails, whatever. And 85% of our servers are working on data. Working on data, it means ingesting data, digesting data, and everything close to real time. So doing this is very expensive. We need to be really smart to keep the business sustainable, because we are kind of expensive, but we try to lower the cost. So here's our. I'm gonna try to present what CFEngine does in case some of you don't really know what it does. Okay, so what the fuck is CFEngine? It's a tool to gently dictate. Mark, don't get mad, Mark. It's a tool to gently dictate what your infrastructure should be. Some history. So 1993 CFEngine. Mark created CFEngine. So to give you an idea, it was when I think Doom went out. The browser was Mosaic at that time. So it's really, it's really impressive. Then 10 years later, we got Puppet. To give you an idea, Amazon released EC2 in 2006. Then version 3 of CFEngine, 2008. Correct me if I'm wrong, Mark. And 2009 Chef. So to give you, to get an abstract overview of the chronology. So here's a simple example of a policy in CFEngine. I don't know if it might not be clear here, but basically it's a very simple policy that installs and sets up a Redis server on servers. Basically, the first part is about packages, telling the servers to install Redis. CFEngine asks the server to install Redis. The second is about the configuration file of Redis, so it's just about copying the configuration file from the policy server to the server itself. The third one is making sure that the Redis process is running, and if it's not, it's going to define a class, and the two promises at the bottom are just telling CFEngine to start Redis if it's not, and to report us by email or in the log that Redis is not running and it just been restarted. So that's a very simple example of how do you define promises in CFEngine. So there is like chef, puppet, and Ansible. So why did we choose CFEngine in the first place? First, the convergence. CFEngine keep promises if it can. If it cannot, it's fine. But it will try. It will try to keep the promises. So a promise is not something that must be done. It's something that you should do if you can. That's what CFEngine is doing. And also, the convergence allows us to start from a not known state. We can install CFEngine on the box. For example, if in the future we're going to merge with other companies, I don't think, but anyway, we can take those servers, install CFEngine on those servers, and it will try to converge those servers into our way, our description of the infrastructure. The second point is portability. CFEngine is running on a lot of platforms compared to the competition. It's not something that we use, but it's still an advantage. Third one is CFEngine is an old piece of software, and I'm not seeing this in a bad way. It's been released in 1993 for the first version, and it's to me, when I had to make the choice, it reassured me because it's been out for like 20 years, 20 years, and there was no known problem. It's like another open source software, like this was OpenBSD. In 15 years, OpenBSD got like 2 security holes in the default install. So it's something when you have to choose a piece of software that's as important as this to manage your infrastructure, you want to be sure that the thing has been beta tested by a lot of people, and 20 years in the field is a lot. But let's focus. I mean, those are advantages, but those are not like why I chose CFEngine in the first place. So here come the real deal breakers that are gonna make you choose CFEngine if you didn't yet. The first one is the language. The dedicated language, the CFEngine DSL, has been really tailored to describe an infrastructure. There is no legacy. It's based on a promise theory that Mark defined, and it's made for this. So there is an example here. For those of you who don't know, the language is like this. You have a promise kind, and you say when and where it's going to be applied, and you say which object you're going to apply the promise. The promise is going to be reflecting. So an example for the Redis server, we are talking about packages. We want this promise to be applied on Ubuntu server on Amazon Web Services. And we are talking about the Redis server package, and we want it to be installed or updated. So that's a very simple example of the DSL. Second point, documented infrastructure. That's very important. The DSL allows us to have an always up-to-date documentation of the infrastructure. That solves, when you have documentation that's not tied to what you have in production, it gets outdated all the time because people don't stick to updating the documentation. So a lot of advantage come out of this. First, any sysadmin can grab the whole cluster. You basically have a bunch of files that define your infrastructure. You just have to grab any information that you want in this cluster. What's in those files is what's live. There is no question, there is no doubt. You know that whatever is there is what's live. There is no need, at some point you don't even need to SSH on the servers anymore. You just define promises with CFEngine and it's going to apply it to the servers, and you can, there is nothing we cannot do. The knowledge is shared among the team. There is nothing that's stuck in the head of some ops out there and that's not documented. If it's on live, it's in those bunch of policies. That's very important because we don't want anyone to keep some information for himself, even if it's not intended. History is kept. If you put those files in some versioning system, you can track what has been made in the past. And that's pretty amazing to be able to see the history of an infrastructure. And last point, for startup, it's valuable because it's investors like to know how your infrastructure is built and have documentation. When you have like the CFEngine policies describing your infrastructure, you have it already. And you don't have to write like 15 pages of document to show it to your investor. You have the documentation always updated. Another point, scalability. When we build something in a startup, we want to build it in case the startup is successful. So we want to build it to scale and not, I mean, you don't want to build something and when you're going to be successful, it's going to fail. So scalability, CFEngine is decentralized by nature. It works like the domain name service. You can build a hierarchical bunch of servers. You can have one server that's going to replicate to two servers, etc., and the clients will ask the bottom server. So it means that we can scale both ways. If the CFEngine server is not big enough to serve your hundreds of servers, you can like just launch a bigger machine, and there is a lot of room. And you can also launch multiple servers to answer even more servers. The largest cluster known, I guess, is multiple hundreds of thousands of servers replying to managed by CFEngine, so that's pretty huge, even bigger than LinkedIn. And our current server is an M1 small on Amazon. To give you an idea, it's a pretty small server. It's half a core. And we start with a micro, to those of you who know. A micro is 10% of a core on Amazon, so it's really cheap. And we had this micro for up to 50 servers. So yeah, it's very effective. Reusability. The language allows us to build things that can be reused. That's very important. Because we are pretty lazy, so we don't like to repeat ourselves. Using CFEngine, we build little blocks of services. For example, one is Redis. The policy that you saw, we can reuse it for every time we want a Redis server live. We can reuse it, so we don't need to rewrite it again. And we also do the same for the servers type. The servers are a bunch of services policies. So, for example, on the server you will have Redis, Apache. On another server you will have Redis and SendMail, and we are going to reuse the Redis block. We also can reuse them for different environments. We don't rewrite the policies for live staging development. We just reuse them. And then when we want to change something, example in the Redis policy, if I want to change the version of Redis, for example, I just have to change it in one place, and it's going to populate on all the servers that use Redis and on all the environments. So that's pretty amazing. The footprint, CFEngine has been tailored to do this, to manage infrastructure. It's tailored for the job. It's very small. The package to install the binary one is smaller than 3 megabytes. The largest binary in the package is 300 kilobytes. We are in 2013, that's pretty rare now to have small things like this. It's written in C, a small, in C++, and the server is just, the job of the server is just to let clients download policies. So basically just serving text file. And that's why it can scale, because it's doing nothing. And all the job is happening on every server on the clients. The clients are trying to appeal policies locally. So that's a very decentralized way of doing things. And that's why it scales so well. One of the points also is GPL. I'm very sensitive about the licenses, and the fact that CFEngine has been in Debian for a very long time is a proof that the license, I mean, it's free not as the money, but free as in libre, which means that if Mark became insane and do something that's gonna screw CFEngine, we can still like fork CFEngine and work on it later. That's not, I'm not gonna fork it, but.
Do you see this happening anytime soon?
And there is an open and active community. It's smaller, no offense, it's smaller than Chef and Puppet, I guess, but it's still there. And there is the fact that we can submit pull requests on GitHub and submit bug reports. I mean, that's a good sign because you know that you can rely on other people's experience and you can also fix or try to understand what's happening in the engine. So here's what we can do because we use CFEngine. First, we own our infrastructure. That's very important. In the past, I've worked with other infrastructure. At some point, as we scale, you just do shards all the time and react. With CFEngine, you can like think ahead and you keep the ownership of your infrastructure. You don't react anymore. You just say, okay, you're gonna do this. We can have a normalized infrastructure. We minimize the redundancy of what we write, of what we describe, and the dependency. We just isolate every task that must be done and every component. We can be unpredictable. It's fun. We kill servers all the time and Percolate. Netflix came up with a script that's called Chaos Monkey. It's open source, you can check it. It randomly kills instances just to make sure that their infrastructure is resilient. We don't do this level of we don't kill randomly, but I do it sometimes. I just like when I want to upgrade something, I just like launch a new server and kill the old server. I don't care if anyone uses it, and that's bring us a spirit of we don't rely on what's live, and we can also make sure that we can, if there is a problem like 2 servers die, we don't really care. It happens all the time. Maintain cost. In the last 2 years, I've joined Percolate 2 years ago. Now we have like 10 times more employees, 20 times more clients, 2 times more servers, and the infrastructure cost only grew by 1.2 times. It's not only because of CFEngine, but CFEngine is one of the reasons that the infrastructure cost didn't grow too much. So it allows us to keep our infrastructure homogeneous. For the same type of task, we know that all the servers are the same. Exception, we are not that much to manage all those servers, so exception just are a waste of time. If there is something different, you just kill the server, launch a new one, and keep everything homogeneous. And we also as ops are not scared of change anymore, because we think ops should serve the team and not slow things down. And that's really people are usually thinking of ops people as people who just don't want to do anything for you. But we like to we like the idea of not being not slowing the velocity of the change in the company. So ops and Percolate. What's really an ops and Percolate? What do we define an ops? I'm sorry if some of you might not agree here, but ops are not DevOps in our case. Ops are just doing their job well. They build, they automate, they maintain, they monitor, they document. They are just, that's what ops should be. It's not a matter of being a developer or whatever. It's just we should do this well, and if automation is part of it, automation should be part of it. And devs also are not DevOps. I see a lot of companies that try to ask their dev to build the infrastructure. I think at some point it's not a good idea. And basically what we ask our dev when they want to build the infrastructure themselves, we just ask them, okay, we just give them some server, they play with it, and they come up with a bunch of commands that they did to describe what they need, and we just translate it in CFEngine recipes. So, because of CFEngine, we can have the same infrastructure on all the environments. The live policies are used to build our staging servers, the same. We don't have a staging policy, live policy, development policy. They are the same. Just for the staging, we launch smaller instances and fewer instances. And we are sure that staging is always up to date with live. Same for development boxes. Our developer, when they started Percolate, they just clone a small repo, which just about configuration file, and they launch a background box that's gonna launch all the policies that are live, and build a small replica of the live infrastructure on their small virtual box, all using the same policies as we have live. So again, the development box are always up to date, and even if we change an already existing development box, the changes are going to be applied. So we are sure that everything is the same on different environments. We can also, because of CFEngine, we can apply the GitHub flow to ops people, which means that when we work on something, we start a new branch on Git. We can test it using Vagrant. We can test the change in the infrastructure. We can review it. I mean, each time there is a change, we just send a pull request to the other ops to just review the infrastructure change. That's something that's pretty amazing compared to before, where you just SSH to a server and did the change. So we can review, merge, and deploy. That's exactly what our developers are doing on the back end. We just do the same on ops. So basically, our responsibility as ops at Percolate is really to use whatever is available, so infrastructure as a service, metal server, and to provide a platform as a service to our developers. And our developers should see us only as a service like Heroku on Google App Engine. And they shouldn't think about how is it built behind. They just ask for an instance and we just give them. But in my mind, CFEngine does not solve all the pieces. I mean, we had to add some stuff around CFEngine to automate everything. First, the bootstrapping of instances. I don't think it's the job of CFEngine to bootstrap, maybe I'm wrong, but anyway, we did it ourselves in Python and in Bash. What bootstrapping means, in our case, is just requesting an instance in Amazon. Give it a name, install CFEngine, and just let it go. So bootstrapping is really the first 3 steps here. Requesting an instance, giving a name, and installing CFEngine. And once CFEngine is installed on an instance that has a name, it defines all the classes needed and just converge the instance to the state that we want it to be. This is the configuration file of our bootstrapper. It's very easy again. There is just, for example, the Facebook.tracker is the kind of part of the name of the instance. We just give it a key, a security group for the firewall rules, an instance type, and a price. And so adding a new type of instance in this bootstrapper is very simple. And these are like, just give an idea of all the options that we can define, but that are implied because they are the default option for all the instances. We can define everything, from the number of instances for this type of job, to the type, to even where CFEngine comes from, the price, everything. And the first line, which shows you that we use, this is very important, we use the official Ubuntu image. We don't have anything. We don't start with anything. We just launch a pristine Ubuntu image on Amazon and bootstrap it by giving a name and installing CFEngine, and CFEngine just converge it. There is no golden image, there is no image that we need to, we don't image any server basically. So how does it work, the bootstrapping? For example, for the cache tracker type of image, I just have one command line, Percolate instance, the name is not great, but this is only this command line. I just run it. The instance will run spot, non-spot, whatever. This is very simple. With this in mind, we don't use CFEngine for complex stuff. We started, at some point, we made some problem when we wanted to build complex script with CFEngine, and it was not doable. So we kind of have a rule now which says that when we have like something which requires 3 order dependencies for complex tasks, like for example deploying a Python application with pip requirements, it doesn't sound complex, but with CFEngine it's hard to keep it readable. So what we do instead is, we just use CFEngine to make sure that the things that are going to do this complex task are there and in a good state, and those tasks are going to be done by Bash script or Python script. So we have a rule where we shouldn't have anything complex in CFEngine because we want to keep it readable and maintainable. To give you an overview of the naming, how we name our instances, because the name is very important. That's the policies are applied on the server based on the name. So the rule that we shows is an environment, which is really the domain name, a role, and a sub-role and an ID. Some example here, we have the smtp.live.com, which means it's a mail server on the live environment. The second is a type of server that's what we call redundant server. We can have like a lot of them doing the same job. So this one is a worker on the live environment. The third line is an API server on the staging environment. And the fourth line is only one server, a load balancer, for the API on the staging environment. So those are the kind of names that we give the instance and that CFEngine is going to use to apply policies to the servers. So that means that our inventory is really our DNS. Every live server has an entry in our DNS. And we leverage it with a coordination service. Now it's the AWS tags, but we reach the limit. It does not scale anymore. We start to get errors, and Amazon doesn't want to scale it up. So we are going to use the keeper in the future to just keep track of what's running and where. The server structure, so it's bottom to top. So we have the EC2 instance, then we launch a persisting Ubuntu. And CFEngine takes care of the basic layer, the environment, and the specialized layer, which is the role of the instance that we launch. And then above this, we have the application layer that's also managed by CFEngine is just making sure that the application layer is fine and in a good state, but really the application layer just manages itself. So CFEngine does not take care of it all, but it takes care of the basic. It makes sure, for the complex things, it makes sure that it's there and operational. So how did we build this infrastructure? We started with the simple and obvious. We started with syslog, SMTP servers, like pieces of the infrastructure that were not critical, because we didn't want to fail big. If it wasn't working, we wanted to be able to roll back and switch to another solution. And then we finished with the critical pieces, and it was, surprisingly at the end, it was really easy to build the most complex instances, because we had already all those pieces that we built with the simple stuff. We just reuse them for the more complex instances. So it was surprisingly easy to finish the infrastructure. So achievements, because we use CFEngine, we got some bonus. First, okay, I'm recapping. So documentation, always up to date, scalability, reusability of what we write, and easy and fast to change the infrastructure, which makes ops more reactive to the demands. But our huge win is our infrastructure has no state. I don't know how to say it in another way, but that's really what it is. We don't have any state. So what's the big deal? The big deal is that our policies, so the description of our infrastructure is in Git. The application code is in Git too. So, and the data is in some data store that are backed up themselves. We have no backup at all. If we build an image of a server, it just cache for us. It just so the server can be launched faster. But we don't even use it. No instance to backup. Two exceptions. We have a Jenkins server that we built under CFEngine. It was really, Jenkins generate config file in XML. It's very hard to handle them. So we just back up the config file each time it's changed over S3. And if the Jenkins instance dies, a new one is going to come up and it's going to get the latest configuration file from S3 on the instance. Everything managed by CFEngine. Again, I'm going to launch an instance named Jenkins, and CFEngine is going to just install all it's pretty complex to install. Second exception, EBS volumes. Some people use EBS for backups. I think it's a bad idea. We use EBS just to keep some state. So RabbitMQ, which is a message queuing protocol server, we don't care if we lose those messages, but it's a comfort to be able to get those messages back if the instance dies. So we have an EBS volume that just persists those messages. So in case of, if the RabbitMQ instance dies, we just have a new one that launches up, and the new instance is just going to mount the EBS volume and get the messages back. But it's really not backup. We don't care if we lose those. It means also that we are independent. As we have no state on Amazon, no AMI, we can migrate away whenever we want. For better price, stability feature, or even for mood, like if we are pissed, we can change. We are not scared. And we know, and here everything is a bonus. We pumped up the volume. We pump the volume up on all the servers. We hear everything that's happening, and we can do this because we just fix and kill any problem. If an instance like go crazy, we just kill it and launch a new one. Our goal is likely to go to 0 email. We're not that far. We are like maybe 10 mails a day for the whole cluster, and that's because all our infrastructure is transparent and homogeneous. We don't push to deploy. We can only do this because, again, our infrastructure is CFEngines. Pushing to deploy a new application does not scale at some point. So we just put a version somewhere and ask the server to pull the version. And when they see that the version that we want is different than the one that they have locally, they just deploy themselves. So the deploy process takes 10 minutes for all the servers. It's decentralized, and we can only do this because we know that all the servers are functional at all times. We don't have like black corner with some server with we don't know what runs on it or how. We are resilient. Any server can go down anytime. We don't care. It's gonna go up again and rebuild itself automatically. It happens every night, so it's not. And we can change our shape. Which means that when the server is if we want to scale vertically, we just launch a new server with the same name. It's going to take the role, and we can kill the old one. And there, we migrated a kind of server to, we upgraded a kind of server with more horsepower for the server. And because of this, we can use spot instances on Amazon. It's very cheap. Spot instance, to give you an idea, Amazon doesn't use all their servers, so the servers that they don't use, they put them available for bidding. We just bid for servers, and if we are the ones with the highest bid, we get the server. But the caveat is that the server can go to any other client anytime. So you need to have a resilient infrastructure for this. That's exactly what we do. It happens every night. We lose some servers. We don't really care. They're just gonna go up at some point. And because of this, we managed to lower the price of infrastructure by 90% off. Because nobody uses a spot instance. We don't really know why, but don't tell your friends. So 90% off. That's pretty amazing of the price of Amazon. And even better is that we use the smaller instance, like T1 micro and one small, are the ones that nobody wants because as you can lose them all the time, it's people I guess are lazy and don't want to set up instances that are like 10% of a core. We don't care, everything is automated, so we can lose any instance and buy them back, and the T1 micro and one small, we use them a lot, and they are very cheap. It's almost finished, so some free tips for the end. First, watch Mark's video. That's the video that I watched when I was still in the choosing which solution to use. This video, especially, I like it. It's about the promise of a system configuration. Second, buy this book. It's not that big, but it's amazing. I bought another book before this one with a big flower, and it almost made me choose another configuration management system. This one, it gives basically what I know you engineer, you have the feeling about I understand this thing when you read something. That's gonna give you this feeling. Yeah, last thing, if you want to work with CFEngine, you should join us. We are looking for people, all the stack, JavaScript, mobile, Python, data, ops. Yeah, thank you. Any question?
Any question over here? Yeah, I just want to ask, your value add is data analytics. You're taking a big scrape of the web and devising plans on how to promote themselves?
Yeah, that's part of the job. Really, the job is about helping the clients. Like every morning, the CMO is gonna open twitter.com and they are like, okay, what am I gonna say today? So we just have servers that, based on the brand, is gonna figure out what happened and what you should talk about, what is becoming popular on the internet. So that's one part. But after, of course, there are all the enterprise features about analytics, how your publication, if your publication did well on Twitter, on Facebook, on LinkedIn, and also the managing the content in those big companies, in different teams, like the legal one, etc. So yeah, it's part of the product.
Okay, but you're not storing a bunch of data. You're really just going out and crawling the web and bringing the data back to yourselves. Or?
Yeah, we ingest what's happening on the web, and we just
you read it.
We manage the content of companies and the publication of content, but that's our primary job is really to ingest content and figure out what's interesting now.
Yeah, so with all this, I think first of all, it's pretty interesting that you don't rely on the instances to be up all the time, that you have this dynamic infrastructure. I mean, it's actually a bit more hostile than the chaos monkey, I think, because it doesn't kill everything, but you have the risk of losing all of them, I guess. But you must have some kind of central store, or as the instances work on some data, they must, otherwise they will lose all their history. So you keep that backed up to some kind of.
Yeah, we have what we keep is really, okay, we have the Git, so the source code of the application, the source code of the infrastructure, and the last part is the data store. Yeah. And the data store, they are not like, well, we can kill some because we are redundant, but basically we have a bunch of MySQL, NoSQL, whatever, and those are treated differently. We have like rolling backups and stuff. So yeah, so this is the only state that we want to keep the data that we crunch and yeah.
Any other questions?
Thank you.
Then that's it. Thank you everybody for coming tonight. Fantastic to see so many faces here. Stick around if you want a little bit longer. We're sort of wrapping up now, but feel free to have another drink, have another chat, and look forward to seeing you somewhere else at another time. Thanks very much.